On today's podcast, we have Eric Topham, the co-founder and CEO of Octaipipe. Eric, thank you so much for joining us on the Reindustrialized podcast. We're super excited to have you here to share more about what you're doing and what you're doing with the company. I guess the best way to start this off is just getting a little bit into your background and your history. You have such an interesting story coming from what a lot of people would say is not necessarily standard for someone now working in the AI space. Can you tell us a little bit about what your start in healthcare and how that led you to where you am today?
Absolutely. Well, first, it's a pleasure to be here, so thank you for having me. Actually, the story goes back a little bit before the healthcare piece, which makes it even stranger. So, so actually, originally, I did my PhD, and my PhD was in a field called community ecology, where actually what I did was use a combination of machine and statistical learning to try and understand the interactions in complex ecological networks. So that's where the machine learning piece originally came from. And then I got towards the end of my PhD, and like a lot of people that go into PhDs thinking that they're going to be an academic, I was like, that's just obviously what I'm going to do. Somewhere along the way, you decide it's not so much for you anymore, and you think of going somewhere else. And I fell somewhat more by chance than design into public health and healthcare research in this world of what outside of academia people were calling data science. So this was back in 2015. And so I sort of landed up doing that for a short number of years, and then again by chance rather than design, I had a meeting on a train with a guy that by the end of the train trip, even though he was a complete stranger, we had more or less decided we would set up a business together. That first business was basically a development, a machine learning development business of building bespoke machine learning systems in industrial applications. So I was kind of coming with the machine learning background. My business partner was coming with 25, 30 years in aerospace and manufacturing. And so that's how that original business started. And then how did we get to where we are today? Well, again, in that in and of itself was a journey. So that first business did perfectly well. We bootstrapped it. It did nicely as a sort of boutique machine learning development house. We sort of specialized in kind of more sort of adventurous and slightly challenging projects. And as part of that ethos, we set up a research collaboration with Imperial College, where we acted as sort of an industrial partner, hosting research students to do these kind of interesting 6-month research projects into kind of more innovative forms of machine learning that we thought would be really applicable to industry, but for which we were certain at the time that the market wasn't yet ready. So it was through that R&D collaboration that we got into a particular type of distributed, privacy-preserving machine learning called federated learning, which is kind of the core technology set that we develop around today, and that we ultimately decided back in sort of 2021 to then effectively evolve that first business around. And really, it's almost like having had two businesses. The business models are completely different. What we do is tangibly different and now much more specialized. But that's kind of the road that we took. So I suppose the common thread was machine learning and complex networks. Then healthcare brings the perspective around data privacy, which is really what this federated learning is targeted towards. And then the first business building models in industry kind of adds the industrial layer. So it's been a kind of sort of like multi-layered journey. And in some ways, that was doing what we're doing now is kind of closing the loop on those three previous chapters. So to outsiders, I can see that it looks kind of a weird journey. Like, no, I didn't go and do machine learning at Stanford, work at DeepMind, and then go out from there. It's been a rather atypical journey. But
I mean, now that you mention that you are studying sort of ecology or computational ecology, it makes a lot of sense, right? That space is all about how you, as you said, take in all of this disparate information and try to make sense of it from a biological perspective. So one of my favorite books actually is a book by Jane Jacobs that talks about sort of the nature of cities, and she uses this like computational ecology approach to be able to explain how things grow and how all these different factors kind of come together, and that's machine learning. Like literally, it's just machine learning.
We're understanding patterns, aren't we? Complex patterns,
which is interesting. So now that path that you describe now, it's not that wild to make sense of.
Once you see how the sausage was made, then it makes perhaps a bit more sense.
So tell us a little bit about what you all are building now.
Yeah. So Octaipipe is a deep tech startup. That's the first thing to say. And what we are building is a machine learning development and operations platform, but that is special in that it is based around a paradigm of machine learning called federated learning, which is an entirely distributed form of machine learning where we, instead of centralizing large volumes of data, as people typically do, into a sort of centralized data store, typically in the public cloud like Azure or Microsoft, instead we do all of our machine learning processing out on what we call the edge, so small, more localized compute close to where data is generated and the systems are functioning. Now, today there are kind of two broad paradigms. There is kind of distributed edge computing and sort of centralized cloud computing for doing this machine learning training and operation. So the downside of each of those is slightly different. So the downside of distributed edge computing is that you will compute your model training at a relatively small scale, localized on relatively constrained compute, just depending on exactly what we mean by edge. But the key point is that localization means that we have smaller scale of data, smaller scale of observations, and that limits the scope, if you like, of what we can achieve with our machine learning.
And to like piggyback on or ask a question there, does that then impact the overall outputs of the learning if we then are, because you talked about a data privacy element as well, so
if you keep the data local like this in this distributed edge computing where you're computing on a single edge node, then that means that you can only use the data that is directly connected to that node. And in industrial applications where perhaps we're trying to estimate the likelihood of a range of different failure types, fortunately failures are rare. So at a very localized level, you won't get many observations of these failures, and so it's then very difficult to generate a good model that can estimate those failures. So it might then restrict you to doing more basic things like simply learning what normal operation looks like, and then having learned what normal operation looks like, simply flagging when you're experiencing abnormal operation. But you can see that me telling you simply that something abnormal is happening is of relatively limited use compared to me telling you exactly what the abnormality is, or even better, when the abnormality might occur. So that's the kind of the downside of this sort of more distributed edge computing where we're computing one model per node. Now, to get the scale, today, the alternative is, okay, well, I'll connect all of those nodes. I'll take all of the data from all of these nodes and I'll move it all up to the cloud. Okay. So now, across my multiple nodes, all up in the cloud, I have sufficient volume and sample size. The challenge with that is that as you hit scale in this kind of centralized model, two things happen. One, you incur risk from a data sovereignty and privacy perspective. Inevitably, as you scale across these nodes, there will be barriers to data sharing that emerge at certain scales. The second piece is that inevitably you're going to incur a cost of the network, cost of the cloud itself. You're going to pay Microsoft and Amazon and GCP for every extra data point that you ingest, egress and process and store, right? And so those costs can become fairly astronomical, and the risk piece means that in certain specific industries that are more sensitive and restrictive from a data point of view, it's basically impossible to sell cloud-based solutions in because of the sensitivity around the data. So I'm thinking of places like defense, semiconductor manufacturing, data centers, some life sciences, chemical process industries that are IP sensitive. And so basically what we do is try and square that circle, get all of the benefit of the sort of data sovereignty and privacy guarantee that you can give through distributed edge computing, but while also getting the scale that you can get with cloud computing.
And that's this federated system.
And that's where this federated learning comes
And so this federated learning then is something that's taking place within the bounds of whatever network you decide to put up. It's not a federated, like in the sense of collectively all of the organizations, but it's federated in the sense that...
you can do it across organizations. Yeah,
okay.
100%. So think of it, let's drop the word federated for a second. Let's think of it as collaborative.
Okay.
So collaborative learning would imply that we have a number of nodes that are each learning something and then collaborating in putting together, if you like, the outcome of that learning process, right? So what we might think of in the sense of a sort of, if we anthropomorphize this, we instruct a number of people to each go out into the world and through their own experience try and learn a particular lesson, some relationship, and then all come back together later at a later point and share what they think they learned that relationship and describe that relationship. And then together we aggregate these different contributions from these collaborating people and we come up with a sort of a global learning of, well, this is what we learned about this relationship, right? Mm-hmm. So what we do is basically the same thing. So rather than centralize lots of data up to the cloud and ask our machine learning to learn one lesson in the cloud, we push a program out to each of these nodes, these edge nodes that, for instance, might be located within a factory. So we might push this out to 100 nodes across 100 factories, where what we're asking the machine learning to learn is the relationship between the likelihood of failure and a set of machine parameters, right? And then what we do is that we learn that relationship, possibly badly, at each of these local nodes. And each local node, once it has learnt that relationship, sends a little message packet back to a central point saying, this is the relationship that I learnt. And then we have an aggregation algorithm that takes all of these collaborating contributions, aggregates them together and says, aha, this is the global nature of the relationship.
Interesting. So the idea then is that the learnings are coming from... like the processing is done, like you said, at the locally at the edge. So the data is never leaving there. And then you have obviously just the relational information that is leaving and then being shared with the system. And is it shared with each node individually for them to process, or is it then centralized in one place?
Well, you could do it that way, but our topology is ironically called centralized federated learning. So we have a centralized node that takes care of doing the aggregation. Yeah, there is use case for doing this more peer-to-peer approach. It's actually something that we're wondering whether we may need to shift to in the future under certain circumstances, but for now this is how we do it. So the process is secured, so we have encryption. We can also add an extra layer of privacy by adding some noise to the process, so that if you think of it as the algorithm not directly seeing the raw data, but it still learns the statistically accurate set of relationships. The importance of that is that we can guarantee that you can't figure out, if you intercept one of these messages or the aggregated model, who took part in the process, nor can you reverse engineer the data from the aggregated model. So it makes it very, very privacy preserving and secure. So they're basically sort of, and you mentioned sort of cross-organization. So we have found that we have sort of three broad contexts in which people want to do this sort of collaborative learning. So the first is perhaps least excitingly, where we have an organization that has a distributed infrastructure, remote operations, where we can't rely on high quality network, high bandwidth. And so these small message packets are advantageous. We can be asynchronous, we can process locally, and we have some cost benefit from minimizing the network and cloud usage.
And that's, I'm guessing, for like some of your like more industrial applications of like hardware or manufacturing, I'm guessing.
Or perhaps things like wind farms and solar farms that are operating remotely. Saudi Aramco have drilling rigs out in the desert and out at sea. That sort of use case. Then we have a second set, which is really much more interesting, which is where we have an original equipment manufacturer that is trying to build machine learning that they want to embed into their products. But their challenge is that all of the data that they need to build this high quality machine learning exists on the customer side, and the customer is generally unwilling to share that data to the OEM. So in fact, we believe that it's less than 20% of the manufacturing market is willing to share their data to an OEM's cloud-based infrastructure.
And when you're saying OEM, are you talking about the final component maker, or are you talking about even individual component makers?
It could be the machine builder, or it could be their sort of tier 1, tier 2. So there are machine builders, but we have been targeting customers like Rockwell and Schneider Electric. And
so they're tier 1 suppliers.
Tier 1 suppliers, and in fact that's where we've had most traction. And the interesting piece here is that they are trying to deal with a problem of product quality, which stems from this issue on the one hand of sort of data privacy and sovereignty. The end operator doesn't like letting their data go out of their control, so they want to keep it locally. But by keeping it locally and forcing the compute to happen locally, now we have this problem of scale, which means that typically a lot of, for instance, in predictive maintenance and condition-based monitoring, a lot of the solutions are deployed on-prem, but that really limits what we can model. But it's very difficult to model particular failure types because we don't have enough volume of scale. So we sort of do this, I say we, not us, the industry does a lot of kind of anomaly detection, but that has an issue for the customer, which is, well, the value of the insight is relatively limited, and so forth. So the OEMs are really kind of looking to find ways of making those products more sellable through additional value. The additional value comes from having access to data at greater scale. We'll come back to that bit in a second.
Wait, I have a question then. So with respect to the kinds of queries that are being asked, are those things, when they're using Octaipipe, do they already have in mind what kind of relationship to the data or what kind of information they want to get out when they're building on the platform?
Actually, I mean, what we're finding is two things. So one, for instance, customers will be able to articulate, it's not good enough for me to know that I have some anomalous asset performance. I want to be told when this asset is likely to fail. So there's a kind of a problem formulation. Now, the user of Octaipipe today is the AI team of, someone like Rockwell or Schneider, that is going to build those models for their customer. Second use case actually is a bit more straightforward, is that very often those companies already have some models that have the right quality of insight, but are predicated on the end customer sending them the data to their customer-facing cloud environment, which some customers don't want to do. Remember, I said there are places like semiconductor manufacturing, data center, life sciences, defense, where we have a natural sensitivity over the data. And so here they have an issue of actually just market access. So they have the models, but they can't serve them into those markets. So here they see us as a vehicle for then serving and scaling those models. So taking a model that's actually already trained, but scaling it into a second, third, fourth customer, updating the models as they go, but to which they don't have direct access to the data.
Now I'm understanding why it makes sense then for there to be potential collaboration, right? Because you're talking to a few tier 1s, but as you start to go down, there might be a need for tier 2, maybe not so much tier 3 suppliers to also have this information so that they're able to build their own models about detection or challenges. And so now you're seeing the opportunity where that information can be shared, and you probably don't want to know necessarily all of the details related to the information on that component, but you do want to share those critical pieces.
So in fact, the machine builders themselves are typically the ones that say, well, we want models that are pre-trained, that we can have installed into our products. We want shorter time. So a lot of the solutions at the moment require the end user, the end customer, to go through a process of configuration, deployment, and what we call training of the models, teaching the models, and that takes time, so that increases the time to value. So the machine builders want to have libraries of pre-trained models, and the tier 1s don't want the risk that's involved in developing models for very specific use cases and all of the costs that goes with it. So the interesting piece is that the tier 1s have looked at what's happened in the world of LLMs. They look at, the GPTs of this world, and they say to themselves, well, those models are great because economically what it means is that you can take that pre-trained, very, very generalizable model, and I can easily specialize it, if you like, fine-tune it, scale it into lots of downstream applications. Think of the number of things that you can do in text with a language model. I was going to say almost infinite, probably not, but you get my point.
A lot of things.
Yeah. So they look at that and say, well, hold on. In industry, historically, the average cost of a project to build a very specific model, typically for a very specific problem, is £1 million to go from nothing to production, often for fairly limited return on investment. Sometimes hard to prove what that impact is. So that's a lot of risk involved. How could we get rid of that risk? Getting rid of the risk would be to have much more general purpose models, what they think of as the industrial foundation model.
Okay.
Well, when you look at the LLM world, the fuel for that was volume of data and cash, right?
Okay.
But capital.
But there was a lot of data.
But there's a lot of data.
So much data.
But here, with the industrial world, where does, from the tier one's perspective, all of that data sit? It sits on the end customer side. So how do they get access to it to build these models? Federated learning gives you a potential solution because you can train these models at scale, but while giving your customer a sovereignty guarantee that their data remains their data, right?
Before our conversation, you spoke about a program that you're part of that is in the UK and in Baden-Württemberg. And I just know the Germans are loving this whenever you bring up the opportunity for this federated learning system. So I'm guessing that you're probably finding a lot of traction there.
Yeah, I mean, it's funny. Germany has been a sort of an early hotbed for federated learning. So Fraunhofer, the research institute, they do a lot around federated learning. Actually, one of our competitors is based in Germany as well. Siemens were an early, should we say, investigator. I'd hesitate to say adopter yet of federated learning.
And isn't there also there's even an organization, global organization for federated learning that's also based in Germany, where the headquarters are there. I'm not sure exactly the name of it, but
are you thinking of Fraunhofer?
No, it's not Fraunhofer. We looked at this when I worked at an organization that focused on data for transportation, and there were a number of systems that talked about mobility. There
are a couple of EU-funded research collaborations. It's true. Yeah, there's one that collaborates also with the Nordics,
exactly.
Germany, and the Nordics. Yeah, I can't remember the name.
I don't know. I don't remember the name either, but I know that it was a huge topic, and I went to a few. I don't want to say panels. They were more like conferences talking about sort of the future of this federated sort of collaboration.
Yeah, and your collaboration, I think. So we found in the last year, federated learning it's a bit of a niche technical topic.
Yeah,
and so we're trying very much to sort of steer clear of it a little bit. Hence the point around collaboration, and try to talk about this in terms of collaborative learning. And the fact that you can solve problems at small scale, but there's benefit to allowing collaboration to achieve, a level of scale that gives you greater value return.
But amongst the people who you're selling to, the word
no, no. I think this is still, federated learning is a pretty niche thing still, right? Like, I mean, the automotive world has done a lot of research and development around it, but very little of it has made it into production. Largely to do with implications with safety certification, where you have autonomous systems and things. Telco equally has done a lot of work in federated learning. I think, again, relatively little of it, from what we've understood, has made it to production due to the kind of monolithic nature of telco infrastructure and the difficulty of changing it. One would hope that, like the guys at Apple have productionized, in the iPhone and so forth. Of course, the poster child was, federated learning for GB board, the predictive text application. So,
I think we'll get there even in advertising soon with the changes that Google is implementing with respect to the way that our browsers will work with respect to cookies.
Well, of course, there's Brave, that are the leading privacy preserving browser. They do a lot of work around federated learning. So it's out there, but it's still relatively niche. And when we talk to customers, the people that are buying are not buying federated learning. They're buying a solution to their addressable market problem. They're buying a solution to their resiliency and efficiency problem. So
can I just interject there? Like, what exactly is the problem? Can you give me an example of what their problem statement would be when they're looking to buy Octaipipe?
This has been our kind of entire challenge for the last sort of year and a half. So for the OEM, if I was to boil it right down, it's that they're looking for an increase in addressable market. So if you're Rockwell Automation, if you're Schneider Electric, there are certain markets that are more restrictive due to the sensitivity of them. Data centers, defense. I mean, I keep listing the same ones. Semiconductor, where what we've learned is that they have issues selling their existing solutions. So it's a market access piece. For the end operator, well, really what they care about is not so much the federated learning piece. What they're interested in is, can I solve some very specific use cases that are to do fundamentally with, operational resiliency, energy efficiency, and so forth. And in some of those more sensitive markets, they want to solve them while at the same time making sure that they keep everything as secure and sovereign as they can.
So in general, so for the first set of customers that you talked about, so these manufacturers who are looking to increase market size, like there are not very many options that they can look to be able to solve their problem, because they need this sort of data preserving or data privacy preserving element. But for the second group of people that you mentioned, who are the end users, they're just looking to sort of solve one particular problem. Like you said, it's resiliency, it's about information. So they have a variety of different sort of not use cases, but players that might be able to offer that solution. Do you find that selling into one is harder than the other?
we did find that selling, ideally we would have liked to sell to the end operator. Okay. Right. So it's a simpler, potentially faster sale, but there were challenges. One, we have been coming along with a platform and saying, hey, you could build all sorts of different solutions with this, and I think operators are very much looking to buy very specific solutions to specific problems. So here we have a friction in the sales process already. Secondly, from the operator's perspective, if you look at these two kind of aspects of risk and cost that we mitigate, you need a specific sort of set of circumstances for the cost element to be sufficiently large. So you need to be basically sampling data at a very high frequency for then your cloud cost to be sufficiently high. Otherwise, typically, and it's about 1 hertz. So if you sample at 1 hertz or slower, then the cloud is viewed as being extremely cost efficient and so on and so forth. That makes sense. The risk piece, here, certain operators, so for instance, in oil and gas, where the infrastructure is distributed and sensitive, there has been, I think, a general kind of will to leave a lot of that data and compute where it is. But
why is that? Are they just afraid of? There's a fear of the risk of.
My perception is that it's two things. Yeah, there's a sensitivity piece, and there is a sort of difficulty of data transfer. Right, if you're offshore and you're relying on VSAT connections. I mean, these days Starlink, I think, is starting to change things, but historically, VSAT, low bandwidth, high cost. Moving lots of data around over to the cloud isn't necessarily easy or financially desirable, I guess. So we have in kind of particularly the manufacturing space, we have found that there's sort of more friction than you would imagine, and coupled with the fact that I think there's an element of having to manage lots of different third-party solutions is difficult for the operator. And in short, the operator isn't going to build their own machine learning unless it is core, or it is, if you like, that the value that machine learning delivers is core to their own
business
proposition and product. So generally, it's to do with quality, for instance. And then anything else outside of that is going to effectively be sort of rented off someone else. All of your predictive maintenance, and so forth, will come from someone else. So now we're back to our, kind of our tier OEMs, tier ones, service providers. Sometimes those two things, one overlays the other. And then when we talk to those guys, again, manufacturing in one place isn't manufacturing in another. The sensitivity isn't the same. So we inevitably get drawn back towards these markets that are more sensitive. And actually for us, I just keep saying manufacturing, but the place that is looking very exciting for us is actually the data center market, right? Which we could think of as sort of data factories, I suppose. But and so here we have the same problems. We have predictive maintenance problems. We have issues of effectively energy consumption efficiency, of effectively productivity of the data center, kind of maximizing the use of the capacity in the data center. So a lot of it's very analogous, but it's just a market that is a little bit more homogenous.
Yeah, for sure.
Has huge growth at the moment. It has, is critical. Can't, data center can't go down, and is massively energy inefficient, and has a big problem to be solved. So we're being, as a business, kind of pulled in that direction, away from kind of sort of traditional sort of asset predictive maintenance, automation.
It's a huge asset. It's just a different one than the way that I think we might traditionally think about. I guess my question is, can you kind of walk me through what the onboarding is like when I'm going to use Octaipipe? I understand like what the product is doing and what service you're providing from the perspective, but I'm curious, like, do I walk in with my wish list of, okay, I'm a data center, I want to know sort of downtime, I want to know like energy, what are the things that I might come in with? First of all, who are you speaking with at the organizations? That's the other part that I'm very curious about. So who are you speaking with? And then what is the list that they come in to say, these are the things that we're really keen on having a good understanding of how they work?
So perhaps I'll use the example of a recent large tier one, I shouldn't say who, but in effect,
we'll use large tier one supplier.
Large tier one supplier. So in effect, what tends to happen is that the business units have some strategic ownership over the solutions that they want to buy. They have their use case lists. In fact, in this case, they have existing models that they already serve through existing products to those portions of the market where there isn't the sensitivity, but they are aware that they have this market access issue, and ultimately they want to be able to access these more restrictive markets and are looking for a way to serve those in with a sufficient degree of privacy preservation and sovereignty guarantee. So then there's a process with those business units and the stakeholders within them, trying to understand what those use cases are, do some prioritization. But then typically these large organizations will have some other stakeholders in the process. So you will have like an AI center of excellence. Typically there's some sort of digital innovation unit. There's the IT function as well. Of course, there's procurement. And so there is some degree of rationalization that is done between these entities, because at least from the central, for instance, IT and AI center of excellence perspective, if the business units have some autonomy about what they want to invest their budgets into, what they also don't want is just a complete smorgasbord of different solutions that then have to be managed. And so from their perspective, they are interested not just in the quality of the machine learning outcome, but also the quality of the infrastructure that you're offering, its usability, maintainability, scalability, security, how it fits within their architecture. One of the big things that we've had to contend with is cost of change. I was saying about sometimes the cost saving you can make on the cloud. We've learned, while it looks really attractive on paper, what you have to factor in is you're going to have to change your architecture, and that has a cost. So then there's a process of going through all of that. Of course, then there's a commercial process that happens, procurement and so forth. Typically, what we do is we try to go through sort of a co-design process with the customer. So where we will take that use case, we will sit down with the customer and think about how that solution is going to be implemented, what the resourcing from both parties is going to be, who's going to build what, if we have to be involved in some building or not, which we generally would rather not be. but unfortunately, new technology, it happens.
You can charge a consulting fee for it.
And there's education and enablement, and we're in a sort of market creation mode as well at the same time. So we do all of that, and then you have proof of concept. Key thing with proof of concepts is going to be that we want really clear success criteria. We want to deliver against those. So typically that's from a kind of process perspective how it works. From a technical perspective, some of it is as easy as going to, for instance, if that tier one is a Microsoft Azure customer, and that's where they have their infrastructure, they go to the Azure store, they find Octaipipe on the store, and in a few clicks they can basically deploy Octaipipe automatically into their infrastructure. And at that point they are sort of up and running.
Oh, wow.
Sort of, because there's some other stuff to do. Then there's a process for doing the onboarding of the devices that they want to register into the platform. So they follow a set of instructions that we do some enablement, with them. Effectively, we sort of follow a process for about 4 weeks of enablement. During that time, they're going to identify, those target devices. They will follow some instructions with some support from us about how to register those devices into Octaipipe. So as long as those devices are on a network, conform to a certain set of specifications, and that they're identifiable, then they can upload that information into Octaipipe. Octaipipe then basically goes out and calls those devices on the network, registers them in, and then they're available for whatever we want to do with them downstream. So that largely is, kind of from the practical perspective. Then the customer can start to do the development they want. We provide, support services and advisory around that process. Generally it's a project that's being executed that we all understand, what the end goal, end state is to be, the KPIs and so forth. And so that's typically how it goes. I did forget, actually, there's always a key step in all of this, which is getting the cybersecurity people happy, and that tends to be the biggest challenge, the longest part. Yeah, exactly. And on the device side, the edge computing piece, either we can drop into kind of brownfield infrastructure, or if customers want to be sort of have their hardware. What's the word I'm looking for here? Software determined, if you like.
Yeah.
So the software drives the hardware design. Then we can also ship with hardware of the right specs, or optimum specs, if you like, for them. Yeah.
Okay. This has been really interesting and riveting. Is there anything else you want to share about Octaipipe before we get into?
I was actually only going to say that we talked about two of the key contexts. There's a third, which is interesting. So we said, just as a reminder, organization with distributed infrastructure, one organization trying to do machine learning across multiple others, and the third is where we have consortia of companies that want to collaborate. Possibly they're even competitors, but collaborate in solving a problem that is a big enough problem for everyone that it's worth collaborating up to a point.
Can you give me an example of what that might look like?
100%. So we have a project at the moment, it's on public record with P&G, that's partially funded by Innovate UK, where P&G with other fast-moving consumer goods companies are looking, and logistics companies looking to build models that predict at a very local level the risk of health and safety near misses and events occurring, right?
Which is like at the production site or
in
the stores?
In the warehouses in this case. So for instance, things like forklift trucks almost hitting someone or hitting someone, right? And we want to kind of estimate the likelihood of those risks occurring in some forward-looking time window. Of course, fortunately, these accidents or near misses are not common. So at individual site level, we have very little data. But if we started to combine together the events that happen across multiple sites and then across multiple entities, we can have sample sizes that are large enough. But of course, you don't want to share your sensitive data about how many near misses you're having in your warehouses. So therefore, sort of privacy or sovereignty preserving collaborative learning allows us to train these models across sites within P&G, across P&G and other organizations, so that they can work together in building a model that benefits everybody and keeping people safe, but without having to compromise that data sovereignty. And there's another use case that we're working on with some partners, so the Centre for Process Innovation, where people that run furnaces for ceramics and glass manufacturing have a big problem, which is that they're extremely energy intensive, but nobody has by themselves a sufficient number of furnaces to model accurately the behavior of the furnace so that we could optimize its control to be as energy efficient as possible. And so it's a sufficiently large problem that a number of these entities are prepared to collaborate together in generating a base model, which then each of them can take a copy away of and do what they want with thereafter. So there's this kind of sort of co-opetition type thing, but it's rather specialized.
I love that. Co-opetition,
yeah, it's a good one. It's rather specialized, and I guess it's something that's difficult commercially because you'll always have a couple of early adopters, but everyone else would rather sit and wait and see what the outcome's going to be.
Exactly.
And so it's incentivizing people is tricky. But it's quite a fascinating sort of separate piece from the other two. But the OEM piece is really where we're focused at the moment. Yeah.
This is great. I am really excited to see how this develops, because it's such a, as you said, like, you're building the market, right? This is not something that's well known with respect to this federated learning in terms of the technology. It's relatively recent in terms of it reaching a level in which it can be useful for these organizations, and you're solving a problem that exists for many people who know that they want to do something, but for other people who are still sort of figuring out what it is that their needs are, they're coming along this learning journey. So it seems that there is a lot of upside in what you all are building with Octaipipe, which is really, really interesting and exciting.
Yeah, thank you.
Now we're moving to the part of the podcast of Reindustrialize where we ask you some rapid fire questions.
Okay. Yep.
And so, yeah, we like pithy, smart comments here. You don't have to spend a lot of time thinking about it. Just give us what comes to top of mind. What's one thing you wish you knew before you started your business?
That selling product is much harder than anybody will ever tell you.
What's the hardest part about being an entrepreneur that no one talks about?
Getting people to see your vision. That's the hardest thing.
What's the best piece of advice you've ever gotten?
Sleep more.
What's your ultimate productivity hack?
Ultimate productivity hack. Don't try and do too much in the morning. Stay up till 1 a.m. because I'm a night person.
Make sure that you know what kind of person you are if you're going to take that advice.
Yeah.
Some people are morning people and some people are night people. Yeah. Catch me at 1 a.m. I'm
productivity band. Yeah, I'm in the zone.
What's one book that every founder should read?
One book that every founder should read. Not a book about work. A book for your enjoyment, to clear your mind and take you away from work. So whatever that happens to be.
What's one habit that you have adopted that's transformed your business?
One habit that I've adopted that's transformed my business. Sleeping more.
That is always a good answer.
Yeah.
And last question, if you could only use one app to run your business, which one would you have to choose?
Probably Outlook, because weirdly I use it as like my main note keeping environment. I don't know why.
That is a throwback, actually.
Yeah, that's a really bad one, isn't it? But yeah, probably of all the things I kind of, maybe I should branch out in the apps that I use. Yeah. I don't know. Weirdly, I'm not sure I would live without Outlook at the moment.
Well, Eric, it's been such a pleasure to learn about your journey and to learn about Octaipipe. And like I said, I'm looking forward to following the success of both you and the company.
Thank you very much. Yeah, it's been really fun. Yeah. Thank you.